Welcome to a reading from the Lucasian Legacy, the Lucasian Professorship of Mathematics at Cambridge University, 1663 to 1993, by Robert Bruen, as read by his son, Garth Bruen. John Colson, 1739 to 1760. From what I have already described, and from many other ingenious devices of the like nature, which I have seen, I shall conclude with this general observation, that the knowledge and use of symbols, or of sensible and arbitrary signs of intellectual ideas, is of the greatest importance in the extent of all parts of mathematics. John Colson. John Colson, 1680 to 1760, the fifth Lucasian Professor of Mathematics at Cambridge University, is a relative unknown in the history of the field. He followed in the wake of Newton's revolution, assuming the chair 12 years after Newton's death, at 52 years after the publication of the Principia. While Colson's original contributions were minor, his translation works had some value. His life was that of an educator more than a scholar. There was some speculation that Cambridge had expected more of him. Before Colson came to Cambridge, he had been the master of mathematical school at Rochester. He was first educated at Christ Church, Oxford, but never graduated. In 1713, he was elected to the Royal Society. In the later years of his life, he was also the rector of Lockington in Yorkshire. Colson was invited to Cambridge to read lectures in mathematics at Sydney College. Eventually, he moved to Emmanuel College, Cambridge, where he received his M.A. in 1728 when he was 48 years old. He was elected to the Lucasian chair in May 1739, which he occupied until his death in 1760. 3 published papers comprise Colson's mathematical contributions, plus one explanatory essay published in Nicholas Saunderson's Elements of Algebra that explains in detail the blind mathematician's system for performing calculations. The topics of the 3 papers include a Latin version on a method for solving quadratic and biquadratic equations, an English paper demonstrating negativo affirmative arithmetic, and the last, in English, a solution to the problem of map-making individual conversion between a flat surface and a spherical surface. The paper discussing negativo affirmative is quite interesting in what it proposes and what it does. The objective was to simplify the arithmetic calculation, which, of course, was done by hand. When numbers containing 10 or more digits are multiplied by numbers of similar size, the calculation takes time. Since science was developing the need for such calculations, any method to speed up the process was welcome. There is no obvious evidence, however, that this method was ever used by anyone else. At the end of the paper, Colson promised to show more of the method and mentioned as an instrument he had contrived called a counting table to aid in using his new method of arithmetic. No follow-up paper appeared, however. The method of negativo affirmative arithmetic was still interesting. Colson found a way to mix negative and positive digits to make up a number. He devised a set of rules to create a negativo affirmative number and another set of rules to return the number to a common one. There are sets of rules for performing the arithmetic as well. Once learned, the method does, in fact, speed up the multiplication of large numbers. Besides mathematics, Colson was fluent in Latin, Italian, and French. His own work was published in both Latin and English, and he did a number of translations in many other areas. When Saunderson's Elements of Algebra was translated into French, Colson's essay on him was translated as well. His first translations were publications for the seafaring community, the Mariner's Magazine, and the Mariner's New Calendar. They contained such topics as geometry, trigonometry, navigation by the heavens day and night, and sailing by Mercator's principles. He commented on and explained much of the material that he translated. From the French, he translated a work of experimental philosophy and a dictionary of the Bible. He translated a work from Latin by a Dutch author in natural philosophy and a book on linear perspective. His most notable translation is probably that of Newton's work. In 1736, he published an English version of Newton's method of fluxions and infinite series, originally written in Latin. In the same year, he also published the English edition of Geometria Analytica by Newton. Each of these translations contains substantial commentary by Colson. In 1761, an edition of Newton's Arithmetica Universalis was published in Latin, with Colson's commentary, also in Latin. Colson showed himself to be ahead of his times by his translation of Analytical Institutions, written originally in Italian by Donna Maria Agnesi, a professor of mathematics and philosophy at the University of Bologna. It was the first book on calculus written by a woman, and Colson intended the translation to make calculus more accessible to women. His manuscript was not published until 1801, 41 years after his death. He had also prepared a manuscript with the same idea in mind called The Plan of the Ladies' System of Analytics, which still remains in the Cambridge Library. Thank you for listening to this segment of The Lucasian Legacy, the Lucasian Professorship of Mathematics at Cambridge University by Robert Bruen. To learn more or support this podcast, go to lucasianchair.org or our Instagram account, Lucasian Legacy.